Hi guys, welcome back, Pre-Algebra students. Saxon, 3rd edition, Algebra 1/2. We're going to be talking about lesson 19 today. If you're following along at home, that's 67, page 67. Symbols for multiplication. This is a big one. You guys, you probably remember in grade school doing this, right? 4 times 3 equals 12. Get rid of that x. Get rid of it. We are in algebra now. We are rarely going to use that because it looks like an x as a variable, right? So what we're going to use instead are 4 times 3 like this. Or you can do 4 times 3 like this. Now, if we're talking about a variable, we can do 3 times x. We don't do a dot or parentheses. That's because we're mathematicians, guys, and we are lazy. We don't want to write anything more than we absolutely have to. Now, for numbers, I obviously have to put something there to say, hey, multiply me, because otherwise it would just look like 43, right? We wouldn't be able to tell the difference between 43 or 4 times 3. But for variables and numbers, you just leave it like this. So get out of that habit where you're doing this, or maybe you're doing this, right? You want to kind of break that habit and make it look, I guess, like your math maturity level, you know, taking it up a notch and making it look like this. That'll show me you're ready for algebra. Okay, so the other thing we're going to do is talk about multiplying fractions. For our first example, and if you'll bear with me here a sec, there we go. 4/9 times 5/7. 4/9 times 5/7. Guys, I love multiplying fractions because it's way easier than adding and subtracting fractions. You do not need a common denominator when you're multiplying fractions. All you do is multiply straight across the top, straight across the bottom. 20 over 63, right? Now, what you do need to ask yourself is, can I reduce this fraction? Because we did talk about that. This is an even, and so you ask 2, 3, or 5. Can I divide it by 2, 3, or 5? Well, 6 plus 3 would give us 9, and 3 goes into 9, but 2 plus 0 is 2, and 3 does not go into 2, so 3 is not going to go into this one, right? And then as far as even numbers go, 2 would go into here, but not into here. 5 would go into here, but not into here. Then there's also 7, that is 7 and 11 and some others, but I don't see that 7 would go into any of those. So I think we're in the clear. That's it. That's as good as it's going to get. But with all fractions, you always want to reduce it unless it tells you otherwise. Okay, that was example number 1. For example number 2, we have 2/3 to the 3rd power. This is saying 2/3 multiplied 3 times. So if we write that out, it's going to look like 2/3 times 2/3 times 2/3. On the top, that's 2 times 2 is 4, times 2 is 8. On the bottom, 3 times 3 is 9, times 3 is 27. 8 over 27 is how you would do that, guys. Okay, so the next one, let's do this. 3 over 8 times 2 over 3. All right, so if you're saying to yourself, multiply straight across the top, straight across the bottom, you are absolutely correct. But guys, we're mathematicians. We are lazy. I don't want to multiply straight across the top, straight across the bottom until I've cross-canceled. And the reason being that then I don't have to reduce at the end, right? So I do it as I'm going along. For example, what this all really means is 3 times 2 up top and 8 times 3 on the bottom. But guys, 8 can be written out as 2 times 4 and 2 times 2. 8 can be written out as 2 times 2 times 2, right? So I'm going to erase that. Instead of writing 8, I'm going to write 2 times 2 times 2 times 3. Okay? So what I can do is get rid of this 3 on top and this 3 on the bottom, this 2, this 2. Guys, if I'm left with nothing up top, that's not actually true. I'm not left with nothing. I'm left with 1. Okay? On the bottom, 2 times 2 is 4. So I get 1 over 4. 1 over 4. Another way that you may see this done, because again, this is math. We like to do things multiple ways just so that you know how to do it. 3 over 8 times 2 over 3. If I look at this and I see, oh, this cancels out with this, right? And then I look at this guy and I think, okay, I can divide this by 2, but if I do it on the top, I have to do it to a number on the bottom. So if I divide this by 2, I get 1. If I divide this by 2, I get 4. And also when I cancel these guys out, I probably should put this, there's 1. So now if you look straight across the top, 1 times 1 is 1, and then on the bottom is 4. So hopefully that helps explain cross-canceling a little bit better. Guys, it is not cross-multiplying. That is when you have an equal sign in the middle. That's when you have something like this. okay? That's when you do this times this equals this times this. That's called cross multiplying. Cross canceling is only during multiplication. All right, so on the next page, there's an example about dividing fractions. Guys, guess what? If you know how to divide fractions, great, but guess what? We don't divide fractions. Throw it out the window. We multiply by the reciprocal. I want you to write divide fractions. You better be taking notes in your notes, guys. Divide fractions. Multiply by the, and I hate this word, reciprocal, reciprocal. I hope I spelled that right. Oh, somebody will correct me if I didn't. All right, so you don't divide fractions, you multiply by the reciprocal. So now that you've got that down, circle it, highlight it, star it, do something. That is just to remind you we do not do this. This is how this works. You keep this first one, 21 over 6. You change this from division to multiplication. You flip this puppy around. So now it is, the reciprocal is just flipping a fraction over like this. All right, so I flipped that around. Guys, sidebar, reciprocal of 7. Well, remember, we can turn anything into a fraction by putting it over 1. So the reciprocal would be 1/7. If I have 8, the reciprocal would be 1/8. Okay. If I have 2/3, the reciprocal would be 3/2. If I have 1/4, the reciprocal would be 4, because I'm just flipping that around. Okay. So keep, change, flip. You may have heard that before, because what we did is we kept this normal. We changed this to multiplication and we flipped this around. All right, guys, already looking at this, see if you can't break things down a little easier. I'm looking at these guys, and although I can't, this one's even, this one's not, so I can't divide by 2. But I look at that, 2 plus 1 is 3, and 3 goes into 3, and 3 goes into 6. So I'm going to divide both these by 3. Divide by 3, divide by 3. I'm going to rewrite my problem. 21 divided by 3 is 7 over 2 times 4 over 27, right? So that's a reducing your fraction is always a good idea before. Otherwise, you're doing 21 times 4, and then you're having to reduce at the end. Now I'm going to cross cancel again. If I divide this by 2, I have to divide something else by 2 up top, right? Divide this by 2, I get 2. So now what I have is 7 times 2, and I can't really, 7 and 2 are prime numbers, and they don't go into 27, so I think I'm done. 7 times 2 is 14. On the bottom, 1 times 27 is 27. So that is your final answer. All right, guys. So take a moment and do the practice problems A through C. They're at the bottom of page 68. So pause the video, do the practice problems, come on back when you are done. All right, guys. So 4/9 and 3/12. I hate parentheses, because when we do, please excuse my dear Aunt Sally, right? Parentheses mean, hey, do everything within those parentheses first. In this case, parentheses just mean multiply. So I'm going to just, and I don't care. Oh, guys, you're showing your work by writing your problems down. I want to see those problems written down. Okay. So looking at this guy, I can cross cancel this. If I divide this by 4, I get 1. Divide this by 4, I get 3, right? Well, I have a 3 here and a 3 here. I can cancel those out and leave it with a 1 and a 1. That looks like an 11 and a 1, right? So I did a double cross cancel, right? 1 times 1 is 1 on the top. 9 times 1 is 9. So there is your answer. You multiplied and then reduced. Again, there's multiple ways of doing this. So if you did it and you got 1/9, have at it. And it wasn't my method, you're fine. 3/8 divided by, you guys remember a fraction bar just means division. Divided by 4/6. Immediately I'm looking at that, let's reduce that 4/6, right? We can cut those in half. This is gonna be 2 and this is gonna be 3, okay? So equals, and you're showing your work by writing the problem down. All right, what this is really saying, though, that's a division bar, right? So what this is saying is 3/8 divided by 2/3, 2/3. But we do not divide fractions, we multiply by the reciprocal. We keep that first one, we change this to a multiplication, and we flip this bad boy around. Okay, good. So now we look at this. 8 is really just 2 times 2 times 2. And this is a 2, but I don't have any 2's up top, so I can't break anything down. So 3 times 3 is 9. 8 times 2 is 16. 2, 3, or 4, none of those go into that, so 9/16 is your answer for B. Just remember a fraction bar is a division bar. C, 4/5 divided by 10/5. We keep that first one, 4/5. We change this into a multiplication and we flip this bad boy around. All right, so that is our new problem. It's multiplication. This 5 is 1. This 5 is 1. Divide both those top and bottom by 5, you get 1. Divide this by 2, I get 2. Divide this by 2, I get 5. So on the top, I have 2 times 1, which is 2. And on the bottom, 1 times 5, which is 5. All right, guys, if you have any questions, let me know. Again, there's multiple ways of doing those. So if you did it something different, just let me know, and we'll go from there. All right, guys, I will see you in class.